Okay. Oh, yes. Oh, nice. Woo. I like this question because it tests your understanding of the concept, okay? Right. So I posted this on Avenue to Learn. You should have this question. Okay, so this is our example number 1. The end of the bar, AB, are confirmed to move along a path shown. At a given instant, A has a velocity of 4 feet per second and acceleration of 7 feet per second. Determine the angular velocity and angular acceleration of AB at this instant. Now, this question has to be treated with caution, okay? And it's pretty straightforward initially, okay? So there are two things that we are going to do over here is we are going to determine omega AB and alpha AB. Okay. Okay, we are going to determine omega AB and we are also going to determine alpha AB. Okay. Now we are going to use two formulas. I'll write up the two formulas straight away. Okay. So we are going to apply VB is equal to VA plus by omega AB cross R B from point A. Okay, so this is our equation number 1. With this expression over here, right, we can more or less determine omega AB. Okay, we can more or less determine omega AB. And why this is important, and why this is important, because we have to apply this formula, AB multiplied by AA plus by alpha AB cross RAB, okay, minus by omega squared. No, this is RBA. Okay. So only after we have determined omega AB, we can plug it into here. Okay, we can plug into there. Okay, so this is the path of solution. Okay, so let's see what we need to determine. Okay, what are the things that we need to determine, or what are the things we can get from this geometry over here? So the first thing that we can do is I'm going to draw a line. This is on Avenue to Learn, right? You all can get the image from Avenue to Learn, right? Okay. So this is 1. And I'm going to call this point C. Okay. So we have to be very cautious when we look at geometry over here. We know the distance from here to here is 2 feet. We are also aware that the distance from here to we are also aware that the distance from here to here is 2 feet. Okay, we are aware of that. Okay, so from here it's very obvious how to find AC. Okay, so we can determine AC is equal to 2 plus by 2 cos 60. Okay. So this is 2 plus by 2 times by cos 60 is equal to 3 feet. So label them as 3I feet, okay, immediately. And then we can know what is BC, right? So this is 2 plus 2 sine 60. It's 3.732. So this value over here, right? So B from point A is 3I plus by 3.732J. Okay, so this is the low-lying fruit. Okay, it's easy to do. Now, the next thing that we're going to do is we're going to find VB. Okay, so the formula that we're going to apply for VB. Okay, so I'll write out the formula that we're going to apply first. So we have VB is equal to VA plus by omega AB cross RB from A. What I'm doing now is I'm doing the analysis first. Okay, I'm doing the analysis first. So from here, right, we know that we have to draw. I want you all to watch how I sketch VB. Okay, so when I draw VB to the center. This is the center O. Okay, and then I'm going to rotate it by 90 degrees. Okay. So from here, we will have two components. Okay. And we know that this is 30 degrees. And we are aware that this is VB. Okay. So we know that we have a minus VB cos 30I, right? And then we have a positive VB sine 30J. Okay. Now at point A, we only have one direction only. So that is pretty straightforward. Okay. Now remember when I drew the VB, the line that I started off is from the center of circle. Yes or no? Right? It's from point O. Are we clear? Right? Because it's rotating by a what? It's rotating by a fixed radius. Okay. Now, pardon my French, where the shit hit the fan, it's here. Okay, okay, I repeat again. Where the shit hit the fan is here. Next thing that we are going to do is we are going to look at acceleration. Okay, so we are going to focus on acceleration. So acceleration at point B is equal to acceleration at point A plus by alpha cross R B from A minus by omega squared RB from A. Yeah. We know that point A is under what? Okay. So i.e. our AAN is equal to what? 0. Okay. Now I want you to focus at point B. And again, I want you all to see how I construct. Okay. So we know that over here, again, this is going to the center of the circle. Okay. So this is point naught. Okay. And then I'm going to construct another arrow. And I'm going to rotate by 90 degrees. Okay. So over here, this is a AB tangential. And then we have what? AB normal. Okay. So take note, the vector AB is pointing towards the what? Center of rotation. And not to point A. Okay, I made that mistake. I assume it pointing towards point A, and it's not towards point. It's rotating about the what? Center of curvature, the center of the radius, okay, of curvature. Where things really look really bad is this now. Okay, so now we know that this is 30 degrees. We are aware that this is 60 degrees. Okay, so we do write the term, we know that this is AB tangential cos 60I. And over here, you have AB T sine 60J. Okay. And then, oh, where 60 come? Eugene, where's 60? Sorry, people. My bad, my bad. Cos 30I sine 30J. And then the next one is where you have ABN. Okay. Sine 60J. And this is going in the minus direction. And you have AB N, and you will have cos 60I. Okay. So just AB alone, right? Just AB alone, you have minus 0.866 ABT in the I direction plus 0.5 ABN in the ABT in the J direction. And then you have minus 0.5 AB, now N in the I direction, and then minus 0.866 A, B, and the J direction. And all this is just for AB. Okay, all this is just for what? AB. Okay, it's not difficult at all. Okay, once you are able to resolve this, okay, it's pretty straightforward. It's not that bad. Okay, it's not that bad. And then important thing to take note, that AN can be equal to omega squared R, okay,